One of the most important applications of the derivative is in optimization problems. So, for example, let's say we have a mathematical model that models the revenue of something, and we might want to maximize the revenue. Or we might have a mathematical model that models costs, and we want to minimize cost. And so there are a lot of applications where we want to optimize or something. So we want to find the maximum or the minimum of a function. And that's what we're going to talk about in this chapter. We're going to talk about finding maxima and minima. Now, maxima and minima are just Latin pluralizations of maximum and minimum. So let's start by talking about some of the vocabulary. So first of all, the points where the value of the function is largest or smallest are referred to as extrema. Those are just the extremes of the function. And there are a couple different kinds of extrema. There are local extrema and global extrema. And let's first of all talk about the local extrema. So any point on the function that is larger than any of the points near it is referred to as a local maximum. So let's take a look at this point right here. You can see it's labeled local maximum, right? So you can see with this point, if we look at any of the points near it, it's greater than all of the other points near it. Now it's obviously not the greatest point on the whole function, because we can see there's another point over here where that's bigger, right? So but again, this is also a local maximum, right? The local this point is greater than all of the points near it. Okay, we also have a local maximum over here. You can see that that point is greater than any point near it. All right, so we can also have local minimums. All right, so if any point on the function that's smaller than all of the points near it is considered a local minimum. Okay, so you can see this one's labeled local minimum. So this point right here is less than any of the points near it. Now, it's obviously not the smallest point on the whole function. We have a point over here that's obviously smaller. But again, this is also, even though it's labeled global minimum, it's also a local minimum because it's smaller than any of the points near it. All right. We also have a local minimum here. Over here, there's a point that's smaller than all of the points near it, and that's a local minimum. All right. So that's the idea of a local minimum. We're just looking in that local area, just in that small area around the point, and not at the whole function. All right. Now, when we look more broadly, we are considering the global maximum and the global minimum. So you can see on this function that's graphed here, at least for the interval that's graphed, it looks like there's this point up here that's labeled global maximum that's bigger than any of the points on that whole interval, and that would be considered a global maximum. We're looking at the whole, broader interval, not just the interval near the point. The same way down here we have this that's labeled global minimum, and you can see on the interval that we know about in this function, it's the smallest point overall. Okay, so the global extrema are just the smallest or the largest points on an interval that we're interested in. Okay, so we have to compare the extrema that we know about and find which one is the biggest or which one is the smallest. All right, so let's take a look at example 1. We're asked to identify the extrema on the interval from 0 to 7. So we're restricting our interval just to from 0 to 7. And we want to find the extrema. So first of all, let's find a local maximum. So we're looking for a point that's bigger than all the points near it. Okay, so if we look at this point right here, you can see that it's bigger than all of the points near it. So we can say that the function has a local maximum of 62. That's the value of the function at x equals 2. Okay, on the interval from 0 to 7. All right, so that would be considered a local maximum because this point is bigger than any of the points near it. We can say that we have a local minimum down here. right? So if I look at this point down here, if I look at any of the points that are just next to it, this point is smaller than any of the points near it, okay? So we can say that this function has a local minimum of 35 at x equals 5. Now, if we look at the whole interval, you can see that those local maximum and local minimum are not the global maximum or minimum. If we look at the whole interval, you can see that we have a point over here that's bigger. Now, this happens to be at one of the endpoints, okay? But we have a global maximum, at least on this interval, of 87, right, at x equals 7. And then down here on the other side, we've got a global minimum of 10 when x is equal to 0. Okay, so we've identified the local and global extrema of this function. Let's take a little closer look at what's happening. In particular, today we're going to focus in on local minimum and local minima and local maxima. So let's take a closer look at this function. So you can see this function is increasing here, 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 right, from this interval from 0 to 2. And then it turns around and starts decreasing. So you can see that the derivative of this function would be negative, right? So you can see we have a case where the derivative would go from positive to negative, and that happens to be where our local maximum occurs, when the slope goes from positive to negative, okay? So you can get an idea of how we might use calculus to find those extrema. At this point down here, you can see on to the left of it, the slope the function is decreasing, the slope is negative, so the derivative would be negative, and then it turns around and becomes positive again. Okay, so again, you can see it's turning around. It's good. The slope is changing from negative to positive, and we end up with a local minimum. Okay, just to give you an idea of where we're going with this and how we might use calculus to find local minimum, minima, and maxima. All right. Well, so that's all I'm going to talk about in this example, and I'll meet you in the next video.